Welcome to all students in subject of design of transmission system. The subject is beam strength. Beam strength of gear tooth. The accurate stress analysis of a gear tooth for a particular application is a complex problem because of the following reasons. There is continuous change in the point of application of load on the tooth profile. The magnitude and direction of applied load also change. In addition to static load, the dynamic load due to inaccuracy of the tooth profile, error in machining and mounting, tooth deflection, acceleration and stress concentration also act on the tooth, which are all difficult to model mathematically. The analysis of bending stress in gear tooth was done by Lewis. The Lewis equation is considered as the basic equation of the design of gears. In the Lewis analysis, the gear tooth is considered as a cantilever beam. In a paper titled The Investigation of the Strength of the Gear Tooth, published in 1892, derived an equation for determining the approximate stress in a gear tooth by treating it as a cantilever beam of a uniform strength. The beam strength calculation is based upon the following assumptions. This is the all factor shown in gear tooth as a cantilever friction. There is tangential force Ft, radial force Fr, resultant force F, height h, distance, thickness T. These are shown as seen. In Lewis consider gear tooth as a gear cantilever beam with a static normal force F applied at the tip. Assumptions made in the derivations are: first, the full load is applied to the tip of a single tooth in static condition. The radial component is negligible. The load is distributed uniformly across the full face width. Force due to tooth sliding friction are negligible. Stress concentration in the tooth fillet is negligible. Here force is denoted by P. In beam strength of gear tooth, the cross section of the tooth varies from the free end to the fixed end. Therefore, a parabola is constructed with the tooth profile. Parabola is beam of uniform strength. The stress at any cross section of beam is uniform or same. The weakest section of the gear tooth is at the section XX, where parabola is tangent to the tooth profile. This is the tooth profile, this is parabola, this is PN, PT, PR. In beam strength of the gear tooth at the section XX, MB is equal to PT into H, I is equal to, moment of inertia is equal to 1 by 12 PT BT cube, Y is equal to T by 2. The bending stress are given by sigma B is equal to MB into Y by L. Rearranging the terms, PT is equal to B sigma B T square upon CH, multiplying the numerator and denominator of the right hand side by M. PT is equal to MB sigma B into T square 6HM. Defining a factor Y is equal to T square by 6HM. The equation is written as PT is equal to MB sigma B Y. Y is called the Lewis form factor. Y is called the Lewis form factor. Y is called the Lewis form factor. Equation 1 gives relationship between the tangential force and the corresponding stress sigma B. When stresses reaches the permissible magnitude of bending stress, the corresponding forces PT is called the beam strength. Therefore, the beam strength sigma SB is the maximum value of the tangential force that the tooth can transmit without bending failure, replacing PT by SB. SB is equal to MB sigma B Y. This is the beam strength of gear tooth calculated by PT max is equal to CS PT. CS is equal to starting torque upon rated torque. For PT max is equal to CS PT. For electric motor, CS is equal to starting torque upon related torque. This is service factor for speed reduction in gearbox. For uniform 1, for moderate shock 1.25, heavy shock 1.75. For light shock it is 1.25, 1.502. For medium shock 1.5, 1.75, 2.25. There is example of driving machines with different working characteristics. For uniform, electric motor, steam turbine, gas turbine. For light shock, multi-cylinder internal combustion engine. Medium shock, single cylinder internal combustion engine. This is the beam strength of gear tooth. There is three conditions: when velocity less than 10 meter per second, CV is equal to 3 upon 3 plus V. CV is equal to when V less than 20 meter per second. CV is equal to 6 upon 6 plus V. CV where V greater than 20 meter per second. CV is equal to 5.6 upon 5.6 plus root of V. And the pitch line velocity is given by V is equal to pi d dash n upon 60 plus upon 60 into 10 raised to 3. P effective is equal to CS PT upon CV. So P effective is equal to CS PT plus PD. The dynamic load is given by PD is equal to 2 LV CEB plus PT upon 2 LV plus root of CEB plus PT, where PD is equal to dynamic load or increment dynamic load is given by N. V is equal to pitch line velocity. Capital C equal to deformation factor. E is equal to sum of errors between two meshing teeth in mm. B is equal to face width of tooth. PT is equal to tangential force due to rated torque. This is the beam strength of gear tooth. C is equal to K upon 1 EP plus 1 EG. K is equal to constant depending upon the form of tooth. EP is equal to modulus of elasticity of pin and material, Newton per mm square. EG equal to modulus of elasticity of gear material, Newton per mm square. K is equal to 0.107 for 14.5 degree full depth teeth. K is equal to 0.111 for 20 degree full depth teeth. This is the beam strength of gear tooth. This is the important formula. SB equal to P effective Fs, where M is equal to 60 into 10 raised to 6 upon pi in bracket KW CS Fs upon Zn CV B by M SUT by 3 into Y bracket raised to 1 by 3. The above equation is used in the preliminary stage of the gear design, where phi is equal to M plus 0.25 root of D dash. D dash is equal to pitch circle diameter in mm. Okay. So we discuss all these things. Now next is problem. A pair of, this is a problem. We calculate the beam strength of gear tooth using this formula. Only using this formula we put these values and we calculate the wear beam strength of the gear tooth. This is the problem on this strength. In next lecture we discuss about this problem. So thanks all of. So in this problem, though this problem we discuss in next lecture. So thanks all of you.